Good morning. This is Mrs. Lekata, a geography teacher at Semahali. Today we are going to deal with the microclimate, and we are going to concentrate much on the valley climates. But before we can do the valley climates, let us go a little bit back about the primary circulation. That the primary circulation is the circulation of air on a larger scale. So the movement of the air across the earth. And from there we have got the secondary circulation. In the secondary circulation, you have concentrated much on the tropical cyclones and the mid-latitude cyclones. So they are still falling in the part of the macro climate. That is the climate on a larger scale. And then this one is the microclimate. Micro meaning small. So we are going to deal with the climate on a local scale or on a smaller scale. Now, we have got three important factors to consider when we deal with these valley climates. So we have got the effect of the aspect. This is the direction in which the slope is facing. So we know that we have got different types of slopes. And then we have got slopes that are facing in the north, and we have got slopes that are facing in the south. We have got the east-facing slopes, and we have got the west-facing slopes. So now we are going to see how the slope is affecting the valley climates. Then we have got the tertiary winds. So these are the winds on a local scale. So we are going to deal with the blowing of the winds on a local scale. Just like in places where you are, winds are blowing, then that will be on a local scale. And sometimes I would love to say, before learners can know what is happening on a larger scale, they should know what is happening on a smaller scale. So these tertiary winds are the local winds where you are, whether you are in Bloemfontein, whether you are in Botshabelo, whether you are in Stensres, it's the local winds. So the temperature inversions. So these are caused by the cold air collecting at the bottom of the valley. Then when we talk of the inversions, we are referring to the increase of temperature with the altitude. In other words, just like as we inverted a glass full of water, so you make it upside down. So the temperature is inverted, because geographically we know that we have got this slogan which says the higher you go, the colder it becomes. But in this case, the temperature is inverted. In this case, when you go higher, then the temperature increases. Then let's start with the aspect, which is the slope. When the sun is shining directly onto the surface will be hotter, and therefore because of the direct of the sun's rays. So we have got the slopes that are facing in the direction of the sun. So in this case, let's talk about the slopes facing in the north. So the north facing slopes are hotter because they are in direct contact with the sun. So sometimes some learners are so confused that why should we say the slopes are facing the north? So whereas the sun is coming from the east. So now in our case, we have got the slopes that are facing in the direction of the equator. Let's say we are in Bloemfontein as we are. Let us look the direction of the sun now. The sun seems to be moving in our northern direction. Therefore, we will find ourselves sitting in the slopes facing the north, because our equator now is as we are moving towards the north. That is why we say the north-facing slopes are more warmer than the south-facing slopes. Let's take, for instance, now as the winter is approaching, in most probably during your breaks, you'll find yourselves sitting in the slopes facing the north. No one will be sitting in the slopes facing the south, because the south-facing slopes are more colder than the north-facing slopes. For an example, let's have a picture like that. Let me draw you a picture like that, right, to see if ever what you are saying is correct. Then this is our north side, and this one is our southern side. Then we have got A, and then we have got B here. Then they want to know if you make a settlement, in which slope will you make a settlement? So you look at the north. This is the direction where our sun is. So because if you are in the southern hemisphere like now our north-facing slopes are warmer because they are facing in the direction of the sun. Then you'll be making a settlement at A. So because that is the warmer slopes. And even at A, but you must mind where exactly at A. So it must be precisely on the thermal belt, of which I'll explain more later. And you cannot make a settlement at B. So this is the south-facing slopes. It is colder. Just as I have given an example of you learners at school. So during breaks, during winter, you find yourselves in the slopes facing the north, rather than the slopes facing the south, because it is colder. So now let us look at our sun. If you look at our sun now, it seems it is drifting towards the north, more further towards the north. So this is an indication to us that even if we want to get the sun's rays, we must be in the slopes facing the north. That is in the direction of the sun. Right. So they say the slopes facing the equator receive direct rays, while the slopes facing the poles receive the oblique rays. So when they talk of the poles here, they're referring in the whole Earth. So we know that the slopes that are facing in the Antarctic, or the slopes facing the Arctic, so they will be colder because they are far away from the equator. Whereas slopes that are facing in the northern direction or towards the equator, they will be warmer. Now they say, as a result, the slopes facing the equator are hotter than the slopes facing away from the equator or to the poles. Now they say the hotter slopes in the southern hemisphere are those that face the north, as I have indicated already, while the south-facing slopes are hotter in the northern hemisphere. Now, the effect of the aspect is greater in winter and in places further from the equator. So now, I'm glad because we are approaching the winter. Now, we know very well that during winter, in the morning or towards sunset, the slopes are becoming quickly colder, and more especially the top slopes. Therefore, the air will be moving down the slope and to collect in the valley. That's why they say this effect of the aspect is greater in winter and in the places further from the equator. And therefore, that is why when people are making their settlements, you will come across it in the settlement geography. The people will be choosing the north-facing slopes and in the thermal belt precisely. So the effect is least noticeable at noon when the sun is nearly directly overhead. Because if it is in the afternoon, this is a little bit noticeable. But towards sunset, you will even feel that when the sun is setting during winter, it is a little bit colder. Just like now, in the morning, it's a little bit chilly. And this will be more effective precisely during winter, in the mornings and in the evenings. So the mountain tops become quickly colder because the coldness concentrates itself on the upper layers of the Earth's surface. And even during sunset, the coldness concentrates itself on the upper layers of the Earth's surface. Therefore, the air will move from the mountain tops into the valley, and the air will be collecting in the valley. Now they say the angle at which the sun's rays strike a slope is called the angle of incidence. So you'll have to look at how the angle is, the sun is striking the slope. Areas falling in the shadow zone of a slope are only heated by reflection. For an example, right. So they say it's an angle of incidence. So let's look at how the sun is striking the earth. Right. So if you look at A and B, then you can see the difference. Now, in some instances, then you can see that the heat on the other side is by means of reflection. The heat is just reflected there. Right. So now the areas falling in the shadow zone, as I have indicated, of a slope, only heated by reflection. The warmest part of the valley is called the thermal belt. This lies below the cold mountain tops, but above the cold valley floor. Let's go back to our diagram. Right, so we have got our diagram there. Then we have got a slope A, and we have got slope B. Then if you want to make your settlement, let's see, the air is flowing down the valley or blowing down the valley, and we have got this one that is the air, warm air that has collected there, which wants to rise. Then this rising air is meeting with the cold air coming down in the middle. That is why they say this is the thermal belt. So the thermal belt is precisely a position where the cold air coming down is meeting with the warm air which is trying to go up. Then we would say it's a mixture of air. Therefore, in settlement geography, the people will make a choice of the settlement in the thermal belt. So because it's a little bit warmer, sometimes we do worry, more especially about people that are not educated as far as settlement geography is concerned. So not educated as they are, but will be surprised when they make a choice for the site for settlement in mountainous areas or in undulating areas. They will choose the slopes facing the north, and they will make their settlement in the thermal belt. Nature tells them, nature teaches them. So it doesn't need necessarily need you to go into the book to have the natural knowledge of the choice of site for settlements. So now that's great of geography, because even if you are not in class, but nature tells you where precisely you have to make your settlement. So we have to make your settlement in the thermal belt. So above the coldness of the floor valley, the floor valley, and between the cold air coming from the upslope. Right. So now they say the warmest part of the valley is called the thermal belt, as I've indicated. This lies below the cold mountain tops, but above the cold valley floor. The slopes facing east are cooler and more moist than the slopes facing west, because the rising sun uses heat as energy to evaporate dew. Now let's look at the east facing slopes. So now those slopes that are facing in the east, they are facing directly where the sun is rising. Therefore, they are moist than the slopes facing the west, because the rising sun, just like in this morning, when the sun rises, so this sun is able to heat the dew, and therefore this water droplets, after some few hours, it will vanish. Then the aspect influences where people settle, as warmer slopes are preferred for settlement. So this is exactly what I've been saying, that the aspect, the direction of the slope is influencing where people settle, as the warmer slopes are preferred for settlement. So let's take for an example in mountainous areas. Right. So you'll find that people are choosing the slopes facing in the north because they are facing in the direction of the equator where the sun is. Now, where precisely in the north-facing slopes will they make their settlement? So we have indicated that in the middle of the slopes, they will settle in the middle of the slopes, because it is exactly where the cold air coming from the mountain tops and from the valley, the warm air from the valley, they meet and they form a thermal belt. So that's where exactly people will make their choice for site for settlement. Now, the natural vegetation is also affected by the aspect. Now, let's look at the plant. The plant types thriving in drier, hotter conditions will be found on the slopes facing the equator. So, because the slopes are facing in the direction of the sun, very hot and dry, and then we'll have some other vegetation that are needing water that will be in the southern facing slopes, which will be wetter than the drier north facing slopes, because the slopes are in direct contact with the sun and are more precisely drier than the south facing slopes. Now, farming is affected by aspect in the same way. Then if you are a farmer, then you have to know what types of crops you plant on the equator facing slopes or the north facing slopes, and the types of crops that you are planting on the south facing slopes, because they are wet slopes. Now we have got examples of this downslopes winds, which is the katabatic winds that we are dealing with more now and again, or time and again. Now they say the katabatic winds occur after midnight, especially if it is a cold, clear, and calm night. So that's why I said this is a very nice lesson to learn, more especially as we are approaching the winter. As I have indicated, the Earth's surface is becoming quickly colder as we are approaching the equator. Now this coldness is concentrating itself on the upper slopes. Then what happens? Then this air, it's heavier, it's much denser, and therefore it flows down the slope. Then the mountain tops, as I've indicated, cool rapidly at night through the terrestrial radiation. So because the heat has been radiated into the atmosphere through long waves, therefore the mountain tops are colder or are cooler. Then the air above the slope becomes cold and dense. It is heavier, and gravity causes it to move down the slope. So now that is why we are having the air moving down the slope. So we say it is the katabatic slope. The kata means down the slope. Now this cold air collects at the bottom of the valley, causing a temperature inversion. So now, as I have indicated, right, so now let's say the air is going down the slope. The air is going down the slope. Then during the day, the whole area was hot, and now as the sun is setting, there is heat that has collected in the valley. So this heat has collected during the day. Therefore, when the mountain tops become cooler during the night, then this air is heavier, as we have indicated. It goes down the slope kata, and as it comes into the valley floor, it finds that there is air that is collected there, which is warm air now. And this warm air has to rise. This cold air, which is now flowing into the valley, it is displacing the warm air that has collected in the valley during the day. So that's why they say this cold air collects at the bottom of the valley, causing the temperature inversion. In other words, the air that has collected in the valley during the day is warm. Now, because this cold air is coming down the slope, it is forcing the warm air, which is light, to rise. Then it causes temperature inversion. So in other words, in this case, the warm air rises. Now the temperature is increasing with the altitude now. So the frost pockets can form on the valley floor. The speed of the wind depends on the steepness of the slope. So if the slope is very steeper, then we know that the winds are very strong. So just like the steeper the gradient, the stronger the wind. So the direction of the wind is determined by the direction in which the valley runs. Then we have got the anabatic winds. So these are the winds that are going up the slope. This occurs after afternoon, or it occurs during the day when it is very hot. Now during the day, we know, just like during the night, the Earth's surface becomes quickly hotter. The heat concentrates itself on the upper layers of the Earth's surface. Now they say the sun's rays warm the slope during the day, and the warm light air above the slope rises up the slope. The aspect can influence the development of this wind. So the slope itself can influence the development of this winds. Now we have got the temperature inversions, as I have indicated. So concentrating on the natural valley inversions. So the katabatic winds, they cause cold air to collect at the bottom of the valley, as we have indicated. Now we have got the natural plateau inversions. In other words, so it's repeating itself that when the mountain tops are cold, we know the pressure is high, and the air is highly dense, then it flows down into the valley, it collects there. Then the air which has been collected there during the day, which is warm, it rises. Then we have got the temperature inversion. So the temperature rises with the altitude. Instead of saying the higher you go, the colder it becomes, in the temperature inversion, the higher you go, the warmer it becomes. Then the cold, clear, calm nighttime conditions result in a lot of terrestrial radiation. So now the heat is now being radiated into the atmosphere. Then you call it the terrestrial radiation. The heat radiated in long waves from the Earth's surface. Now the Earth's surface cools, causing the air above it to become cool. Then we have got this night time. The industrial built in a valley must have their chimneys stacks stretching above the inversion layer so that the pollution can rise and not be trapped in the stable air below. So now that is why, as one of the questions in the November, they like much to ask you about this, where you indicate that to keep the pollution away from the area, we can make a stack of chimneys from the industry so that this pollution cannot concentrate in the area. So it must be kept away from the area. Hi, then we have got the dew and the frost. Excuse me. So the dew and the frost form under nighttime inversions conditions if the air directly above the Earth's surface cools to dew point temperature. So, and our learners must be able to differentiate between dew and frost. Now, because we are still having summer, though we are going to winter, we are talking about dew. So that when you wake up, you find the lawns or your flowers full of water droplets, then that one will be dew. But as we are approaching the winter, we are getting right into winter, then we'll be talking about frost. Then when you wake up, then on the lawns there are these ice crystals, so on the flowers, and that is why sometimes during winter some people will even cover their flowers with some plastics to protect them against this frost. So now this water droplets will frozen below dew point. Then they say the frost occurs in winter when the dew point temperature is below freezing. So then in that case, it will no longer be dew. Then we'll be talking about frost. And I'd like you to be observant, because this is the correct time of learning what we are saying as we are moving from summer to winter. So to differentiate between dew and to differentiate between dew and the frost. So now as we are still in the summer part, the summer portion, the water droplets that you are seeing when you wake up is the dew point. But somewhere in the end of April to May, then you'll be no longer talking about dew point, you'll be talking about frost. So because the temperature will be now, dew point will be now below freezing point. So owing to the occurrence of the frost on the valley floors, only frost-resistant crops should be planted in the valley. So that's why we should know which crops we plant during winter and which crops will we plant during summer. So the frost-resistant crops can be planted during the winter. So because if you take a risk of planting the summer crops, one day when you wake up, you'll find them so black. So that is why we'll be talking of the black frost. Now, let us look at the mist and the fog. So if there is a light wind, condensation occurs slightly above the Earth's surface and causing mist and fog. But fog will be very thick. It is thicker than mist. And we have got the smoke, which is fog. Smoke is fog, and therefore it gives pollution. So this is what I've been having for you as far as the valley climate is concerned. It's a very short lesson, and then I think you have enjoyed it. So please bear in mind that this tertiary circulation, it's very interesting because it's a local winds. It affects you day and night, and you rather start being observant of what is happening. And then it goes hand with the city climates, of which I think someone will treat it. Thank you. I have enjoyed a lesson with you, and I think you also did enjoy this lesson. Thank you much.